know which variable we're looking for, this becomes a supervised learning model. We decided to test 3 different models: the decision tree, naive Bayes, and neural nets. We wanted to be very scientific about it and see which one would give us the best results. We built out all 3 models, starting with the Reed CSV, and then we were able to filter out some of the example set. We did run into an issue where most of the values were between 0 and 1, and then a small fraction of the sample set showed a value of -99. So we were able to filter those out. We also had to set the row for our target variable, which was to see if an item was going to go on to back order. From there, we used a split validation to test and see how accurate the models were at being able to predict if an item would go on back order. Okay, so when we first ran the model, you can see the decision tree was highly accurate. It had an accuracy rating of 97, over 97%. However, it was accurate because it didn't choose anything to go on back order. So our target variable was a very rare event, and it occurred less than 2% of the time. So the issue becomes these models are designed to be accurate, and this one was highly accurate. However, it's not finding the target variable that we're looking for. So this became an issue when we were initially building the model. Okay, and we did have a similar issue with the naive Bayes model. It didn't come out as accurate as we'd like, but most importantly, the neural net model was very problematic. We built out the model using my old cheap laptop that I have. I don't know if you can see it, the screenshot. I ran it for over 2 hours and still didn't get a result. Okay, neural nets are very computational intensive. Some options to counter that. A lot of high-powered computers now have GPUs to deal with neural nets. There are some services through AWS where you could actually compute your model in the cloud. I chose not to do this, and what we decided was just to find another option to make possible to build our models given the limited computational power that I had. So we had to go back to the drawing board. Okay, so what we did was we set out an absolute sample operator, and what you'll see is we did a 50-50 split. So rather than have something going on back order as a very rare event, we set that at 7,000 and then another 7,000 for an item not going on back order. That way the model gets to train off of more examples of something going on back order. Okay. So some of the challenges in building the model: the data set was very large. We had over 1 million rows. So this is a real challenge that a lot of people in this field are facing, right? So there's a lot of learning that we got out of this experience. Also, when your target variable is something very rare, as you can see, you have a tendency for the model to say, okay, it's not going to go on back order, I'm accurate. But that doesn't give you any insight, right? Probably before even running the models, the business already knew there was a rare event for something to go on back order. And they'd probably been doing a good job to try and prevent this. What we're trying to do is create something that's even better. Also, we need to know the cost-benefit analysis. So let's say if we can predict, something's going to go on back order, you have to consider also inventory cost. So this is something that needs to be done. In other words, you don't want the cure to be worse than the disease. So that needs to be taken into consideration when running these models. Okay. So we ran all three models, and this is a comparison chart to see what the results are that we got. What you'll see is the decision tree came out very strong. Okay, it had a reasonably high accuracy rate. The recall was good. So also there's some advantages with the decision tree, right? The decision tree can tell you what's going on versus the neural net model, which doesn't necessarily let you know what the issue is. Another thing I want to point out is the naive Bayesian scored very low, but it had actually a little higher recall rate, and it's actually at 98.7%. We'll talk about that a little bit later. Okay, so we also wanted to check our models for robustness. So what you'll see is we have the initial model that we've built out. RapidMiner has a very good choice where you could just copy operators. So that's what was done here. So we've taken our read CSV set. Now this time we use a stratified sample set, and we're going to apply our model to that stratified sample set to see where it is, right? Because that would be closer to the actual data that we would be looking at in the future. Okay, so as we ran it, what you will see, I think the decision tree came out as far as the strongest model across the board. All the attributes seem to be higher than others. What you will see here is that our naive Bayes does a really good job on the recall for items that went on back order. However, the accuracy is very low. So this could create a problem, right? It's able to catch all the items that go on back order, but it's also prescribing items going on back order that would not necessarily go on back order. So this could cause a case where the cure is worse than the disease, because let's say if we're trying to solve the issue of items being out of stock by putting them in your inventory, well, that comes with cost, right? So if you have items that actually don't end up going on back order and you've put them in inventory, that could be very expensive, and that could cause the profits that you once had to basically evaporate. So the decision tree has the advantage that we can see which factors led to the target variable. So things such as the amount in your inventory, the forecasted sales, the sales that you've had in the trailing 3 or 6 months. These are all good indicators that something's going to go on back order. So another thing to look at, rather than just say, okay, as a business, we want nothing to go on back order. From the literature, one of the best options that you have to prevent an item from going on back order is to issue or to sell something by auction. Okay, recall that the naive Bayes model had a very good recall amount for items going on back order. So assuming that the transaction costs of putting an item through an auction system is very small, what you could do is take these items that the naive Bayes is predicting would go on back order, and have them auctioned off rather than try and say, okay, we just want to make sure we never run out of something, right? Remember, if we're able to auction it off and there's a shortage, we're going to get a higher price, which amounts to better profits. So this would have to be calculated, but I think this is something that could be very, very beneficial to a business. Okay, the references that we used was from Jeff Klein. It was a study of backorder costs. Also, we looked at backorder compensation mechanisms. This is where we came up with the idea. Maybe it would be best to target items that would go on backorder and then put them through the auction mechanism where you know you're most likely going to get, if not the fair market value, but a higher price. Thank you very much for watching. Have a great day.